Good evening all of you, and here is very interesting questions of rock and roll. So basically what we are going to see today is a parabola, hyperbola or ellipse or line or circles. They can roll on other curve, and then we need to find locus of maybe a fixed point on the curve or locus of focus or locus of center or vertex according to the nature of the curves. So let's start with the simple one. So here is a fixed parabola, y equals minus x square. You can see in this diagram, and we have a variable parabola y equals x square. We need to find the locus of focus of y equals x square as it rolls on y equals minus x square. Take a particular point P on this parabola, of course on a variable parabola. So the length of the arc OP will be fixed, right? Now can you track the position of P once this parabola, a red guy has slid, both of these parabola is congruent. Hence, as the red guy is sliding over this fixed parabola, we can just find the image of focus in the tangent drawn at the point of contact. So let's say P is a point of contact. If I'll find the image of S in the tangent at the point of contact P, that will directly give locus of focus as the answer. And that's very easy to calculate because you know we have a fixed parabola, and if we have a random point P on the fixed parabola, the locus of image of focus will lie on directrix. So hence for this question, the locus of focus of variable parabola y equals x square is nothing but a straight line, which is basically directrix to another problem. Let E1 be with the fixed ellipse and E2 is free. If E2 is sliding over or rolling over, if E2 is rolling over E1, we need to find locus of focus of E2 and locus of center of E2. So clearly we can see, again the size of both of these ellipses is same. So since size is same, so still we can use the symmetricity argument. Okay, now why basically we have used the symmetricity argument in parabola or ellipse or maybe two circles of same size? For circles you have like less freedom. So that makes the problem easy. So let's understand with this point. Let's say we have a fixed ellipse C1 and E2 is a variable ellipse, okay, which will roll without sliding. So I've given one specific situations, and let's analyze the problem in this specific situation. Let's say at any point we have a point P on the ellipse, right? So this is the starting point. Let's say the point P was here at t equal to 0. As it starts rolling, we are taking the snapshot of that. So after some time, what will happen? These two distances is gonna be same, right? So if it is r and theta for that point, so the center is still at r and theta. At point P, if I draw tangent, so these angles made will be strictly same, right? So in general, what we can tell is these two chunks of triangle is congruent. Since they are congruent, hence this is isosceles, of course. Moreover, these two angles are equal. So that clearly gives these two angles to be equal. Hence the image of center of this ellipse 0, 0, which is origin, in the tangent T is nothing but the center of the variable ellipse. So just to find the center of ellipse, we need to reflect origin in a random tangent line to the fixed ellipse. Also find the equation of the same tangent line using this alpha beta, because the midpoint is going to be alpha by 2 comma beta by 2. Hence the equation is nothing but y minus beta by 2 equals slope. So slope of this guy is minus alpha by beta equals x minus alpha. Now we know this both equations must be identical, so we'll take the ratio coefficient to be equal. So let little bit arrange this in this form. Beta by 2 plus alpha square by 2 beta. Alpha equals 2y alpha by beta is beta by 2 plus alpha square by 2 beta. Now we can easily eliminate alpha, which gives a relation between alpha and beta. So since sin square alpha plus cos square alpha equals 1, that will give the answer 3y beta by 2 plus alpha square by 2 beta whole square plus 4 alpha square by beta square into beta square by 2 plus alpha square by 2 beta whole square equals 1. And you can clearly see this is a 4-degree expression. So it's 4-degree curve. And clearly it's not a circle. So the locus that we'll get is something like this. Okay, it will be deviated from the circle. Deviated from circle. The next question was to find the locus of focus. Now that still can be done by simply taking the reflection of the focus alpha comma 0 into any random tangent. But this can be done in a simple way. We know at the point of contact P, F2P plus F1P equals 2A. That's virtue of ellipse property. If I reflect F1, let's say reflection is some F1 dash. Now my claim is F1 dash P and F2 will be collinear. Now it's not that difficult to prove because by the reflection property of ellipse, if I draw normal over here, these two angles are same theta. Since the remaining angle is going to be 90 minus theta and 90 minus theta. Now what about this angle? As we know, the triangle, let's say foot of perpendicular drawn from F1 to any tangent T equals 0 is some P, let's say some F, because P I've already used. So let's say foot of perpendicular is F. Then these two triangles PF F1 and PF F1 dash is congruent because we have reflected F1 in this line. So these two are equals, is 90, this is common, so by RHS by ASA congruency. Because we have reflected this, so these two are congruent because of SAS, right? So from congruency we can easily check this angle is theta as well. So the overall angle made at point P is 180 degree. Hence point P, F2 and F dash must be collinear. And that surprisingly solves the question because it shows F1 dash F2 is always constant, which is 2A. That is same as F1P plus F2P. Now F2 is a fixed point. 2A value is fixed because once ellipse is fixed, 2A is fixed. So the locus of F1 dash must be a circle. It shows F1 dash is at a constant distance of F2 as tangent changes its configuration. One of the most challenging questions, which probably JEE might not ask, will be this. We have a parabola y equals x square, and now it's rolling on a straight line, let's say x-axis. And then we need to find the locus of focus of the parabola. So I've given some image or diagram here. You can see we have a straight line over here, and 3 configuration of parabola I've drawn just to give you a feel. So initially a red guy, and then with other colors, and then black color, green and black represents 3 different situations. So clearly you can see like focus is trying to follow some clue. So how to solve these questions? If a parabola y equals x square is rolling over x-axis without slipping, find the locus of focus. This might seem easier than both of those questions, but interestingly it's more challenging. The reason you'll get to know soon. So what I've done, let's say we start with a random point P and see how this point behaves as the parabola starts rolling. Okay, because the entire parabola roll is equivalent to the sum collections of all point P on the parabola. So the entire genetics of parabola will be captured by this point P. So let's say P is t comma t square, some random point t on y equals x square, and SP distance is denoted by d. We have drawn a tangent. Let's say it makes an angle theta1 with the x-axis and anti-clockwise sense. Alpha is the angle between tangent line and S1P. So we can easily see like focus for this parabola is going to be 0, 1 by 4 because it can be written as x square equal to 4 to 1 by 4 into 1. So what will be the slope of line at point T? It's 2t. So hence tan theta1 value is 2t. We also know SP slope, right? SP slope is nothing because this focus is 0, 1 by 4, hence is t square minus 1 by 4 by t. So once SP slope and the slope of tangent is known, alpha can easily be found with tan theta m1 minus m2. So hence if SP slope and the slope of tangent is known, we can find the angle included in between also. Let's see what happens to this when this parabola, when the point P matches with the x-axis. So this is roughly the diagram. I'm not so good at diagram, but it will give you enough feel of the situation. So clearly now vertex will go somewhere. And as we can see, the amount by which, because if it is rolling without slipping, the arc length PB will exactly be shifted on the straight line, right? So that arc length PB, somewhere initially point P was there. So this arc length was exactly this. So let's say in this configuration, S dash is the new focus, and we need to find the locus of focus x comma y relation. Still the distance between S dash and P dash will be same d. Why? Because you can see this entire sheet, I can imagine if it is a metal wire. And the entire system rolls. So the relative distance will not change, right? So hence S1, S dash and P dash is d. And the angle, that the tangent. So now the tangent line will become an x-axis, right? So still angle will be alpha. And the distance BP dash is nothing but the length of the arc, because this length is being slided on the x-axis. So it is unfolding itself on x-axis. Hence length of arc is nothing but S there. So from here we got very simple relation. S equals ST minus D cos alpha. If this distance is D, this projection if I draw, we'll have this distance as D cos alpha and height is D sin alpha, right? So x coordinate of the point is just this distance, which is total S minus D cos alpha, and y coordinate is D sin alpha. And 10 alpha I have calculated, which is 2t, where alpha was the angle between this. So using m1 minus m2 by 1 plus m1 m2. Okay. So from here, once we know the value of 10 alpha, we can easily see what is cos alpha and sin alpha in terms of t, right? 10 alpha is 2t, so it's a right angle triangle. Hence we know cos and sin. Now the important point is to relate x and y, we need to find the arc length st. Now how to find the arc length for a general 2-degree curve? So here is a basic idea. So logic is if you have a general 2-degree curve, and if I take 2 points very close to each other, let's say the one point is t comma ft in terms of parameter, other is t plus delta t comma f of t plus delta t. Okay, or you can tell if one point is x comma y, other is going to be x plus delta x comma y plus delta y. Now when delta x and delta y is very small, we can simply use distance formula to find this length, because arc will behave more or less as straight line. So using Pythagoras theorem, the distance PQ is nothing but root over delta y square plus delta x. If we'll take this is a small length, let's call dl. So what we'll do, we'll integrate this entire length from maybe x1 to x2, and that will give the length of the curve. So maybe we'll integrate this from x1 to x2 delta y square plus del x square. Now in the limiting case, when delta y is very small or delta x is very small, of course the y coordinate will also be small. So this will term as, I can take delta x out, 1 plus delta y delta x whole square. And that, okay. So basically this summation becomes integration, right? So delta x becomes dx, and that becomes 1 plus dy by dx square. So this is the general formula for finding the length of the curve, which I proved just now. Now just we need to put dy by dx, means slope of the tangent at any point, which is 2t over here, and that will give you length from 0 to t. Okay, so this arc length is nothing but 0 to t integral of 1 plus dy dx whole square dx. So that is this expression, and we can use the formula for a to b root over a square plus x square dx. This is just in the result, as you already know, x root a square plus x square 2 plus 1 by 2 ln in that term. So by using this formula, straightforward, we are getting this huge expressions for st. The next calculation is d, because we have already found cos alpha and sin alpha in terms of t as a parameter. So what is distance d? Now that's quite simple, because d is distance from 0 comma 1 by 4 to t comma t square. So that's gonna be t square minus 0 whole square plus t minus 1 by 4 square root. So that distance is t square plus 1 by 4. You can look upon this distance from parabola property also, because this distance is nothing but SP equals PT, distance from directrix. And since this gap is 1 by 4 and the y coordinate is t square, and this is t square plus 1 by 4. Now plugging the value of d and st here, the value of x and y is not that complicated. So xt we are getting 1 by 4 ln 2t plus 2 root t square plus 1 by 4, and yt is half root t square plus 1 by 4. From the first equation we can easily eliminate t because 4 goes that side, and so e to the power 4x equals 2t plus 2 times this, e to the power 4x minus 2t. If we let's square it, directly we'll get the value of t as e to the power 4x minus e to the power minus 4x by 2. If I plug this value in the y coordinate we got in terms of x coordinate. So it's a minus b whole square plus something that can be written as a plus b whole square plus 4ab. So y value we got in terms of x, which comes down to be 1 by 8 e to the power 4x plus e to the power minus. And that's the answer for this beautiful problem. You can clearly see the answer is surprisingly beautiful, and moreover it is giving invitation to exponential, which was purely non-intuitive mathematically. Okay, because we know like physically there will be some curve, it can be crazy, it might not be a nicer curve like circle with straight line or parabola or hyperbola, but that craziness is inviting exponential. Okay, and that was the biggest kind of non-intuitive answer that we are getting.